So today we're going to talk about some common distributions. The three distributions we're going to talk about are the normal, the skewed, and the binomial. Okay, so the normal distribution looks like this, right? Basically what it tells us is that the mean, median, and mode, when you look at the normal distribution, they're all located at the center. Basically, all three measures of central tendency end up being right at that peak. That's it. So now I'm just going to give you an example of something that represents a normal distribution. Okay? So an example of a normal distribution is this set here. It's going to be in blue. So as you see the set here, right, we basically have our mean being at the center. The median is also at the center. And the mode is also, well, it's 80, isn't it? Right? So basically that's what we have for something that is normally distributed. We have an equal number of points above and below as well. Now, when we take a look at this thing called the skewed distribution, right, this is data that looks like a normal distribution here, but the only issue is that the median mode, and the mean all push either right or left of the center. So that's what we call a basic skewed distribution, right? Okay, so the peak ends up being here, and basically that's it, where that peak is actually the mode of what we see on our graph, right? So sometimes the graph will look like this, or it would go from right to left or left to right. It's up to what the data looks like. So in red, I'm going to create another list that will give you an idea of what that looks like. So when we take a look at this red list here, you go and average all of this, and you'll find out that the average is 10. And you'll notice that the mode is the 6s that we have here, right? So that's what's happening. And the median is the number 8 in the center. So basically that's what's actually happening here. We have all of these three things happening all at once, but the peak is at 6, this biggest number of 6s, and then the median ends up being 8, and then the mean is pushed off to the right a little bit. Okay, now let's talk about a binomial distribution, bimodal distribution. So here's what's happening. You have two peaks, literally two peaks in a binomial distribution. If you wanted to, you could literally split the two peaks, right? So basically, a single measure that we have, none of those measures tend to work, right? So here's your median. Well, this one here is the largest thing, so guess what? This is our mode. Oh my goodness. And the mean is somewhere over here. Or it could be over to the right, but we know it's not in the center, because this basic column right here has more data to it. So it shifted the mean off to the right, i.e. the average of all the data points. Okay, so these are all the different kinds of distributions. So now let's go and use that to our advantage for every problem that we come up with. So let's just keep those pictures up. So we know that this is a normal distribution. This one here is a skewed because it's pushed off to the left, and this one is bimodal. So let's look at each of these different cases that we have to work with. In each case, predict the shape of the distribution and give a reason for it. All right, for this first problem, we have the cost of 1 liter of gasoline in the city in Ontario, right? Now, the reason why we would call this a normal distribution is because 1, there are lots of gas stations all over Ontario. 2, many charge an average price, okay? So like when you go to Hamilton, you might be paying $1.40. You go over to Niagara Falls and you're still paying about $1.40. If you'd like drive all the way to Timmins, you're paying maybe $1.38 to $1.40 for your average price. They also, few charge less than average because all of these companies want to make money. And the last thing, a few charge more in price, not a lot of them. And that's why you would have a normal distribution. So that's it. So literally, a lot of them are actually selling at the right price, and some are selling less, and some are selling more. So now let's consider the heights of basketball players in the NBA, right? So if you think about it, right, most of the basketball players are pretty tall, aren't they? And that's compared to the normal population. So this is probably skewed. If you think about it, more of the people in the NBA are going to be taller. And as a coach, in order to be successful in the NBA, you kind of want most of the people being a lot taller than the average person, right? So that means there's going to be very few people that are very short, right? But then there's going to be a lot more people that are very tall, and a lot of them are very close to being the same height. So now let's take a look at the masses of players in the Olympic men's and women's hockey team. I'm going to assume that all of them are in one big pool, right? But I'm going to tell you that there's going to be two masses, i.e. their weights are going to be different. There's going to be two means, one for the men and one for the women, because a man and a woman are kind of built a little differently, and men tend to be a little bigger, and so we should have a bimodal distribution. Here's my answer. So if we compare mass to frequency, I'm guessing that for mass, we end up having we have two different peaks. We have one for men and one for women. So one mean is for the women's mass, and one is for the men's mass. I don't know which one it is, but this does make sense to have two different possibilities described in our mass index graph. All right, so imagine you have this example. Frank has the heights of Pee Wee and senior girls soccer teams, right? You'll notice that for each of these heights, we have all these ranges, right? Now, the square brackets on the right side of this thing means the following. Include the 100. So if I had a square bracket before the 100, it means include the lower 100, but the round bracket says don't include that number. So if I'm looking at this category here for height, it says start at 100, but go all the way up to, but not including 110. So I might have 109.5, and that stays in that side of my number. But if I start with 110, that is the new category. So now what we have to do is display this data that we have here using height and frequency, right? On this graph in some form of histogram. Now you need to be able to do something like this by hand, right? So let me show you how we're going to do it. Now it says place a point at the top center of each bar in your histogram and join those points on a smooth curve. So remember, a histogram is nothing more than a bar chart. So first we got to go and label, we have to basically mark off all of our different ranges. So the first thing I'm going to do is show that I've got like a small change between 0 and 100. I'm not going to go and do anything past 100, less than 100. And then I'm going to label all the numbers from 100 to about the last value on our height chart, which is 160. All right, so we have our numbers written down along the x-axis for all our categories. Now the key is for all of these things, the categories always go on the x-axis. Now that I've done that, I need to label the axes. Make sure you do it. On the x-axis, we have our height, and we have our frequency on our y-axis. So our y-axis is just the number of times something happens. And now that we've done that, what we have to do now is just draw each of the columns. Okay, so I'll show you the first one. For 100 to 110, we have 4. And that's pretty much what we do. And now we'll do the rest. So for 110 to 120, but not including, we have 8. So I'm going to draw a line across the top and then just draw a line straight down to the axis and then filler in. All right, so now there's our graph. Now it also says that we need to put a dot in the middle of every one of those columns at the top. So let's do that. And using that, now we can go and draw we can connect the dots and we can see that our graph, our histogram, has 2 humps. Now that 2 humps tells us that this is bimodal. Okay. So the next question asks us to classify the distribution, and you're going to say it's bimodal. And it tells us that because there's 2 humps, there's a different height there's a different average height between peewee and senior girls. So when we're looking for the mean, we're looking for approximately the center, right? So approximately the center of this entire thing is about 130. So let's move on to the last question of this problem. It says approximate the mean, the median, and the mode. All right, so here is the median and the mean. So the mean we said was about 130. Okay, and then the mode is, I've got 2 of them. Both of these numbers have a frequency of 8. So you can see it here in our chart. You can see it here in our table here, right? Our table has 8 and that, right? So basically what we're going to do is you're going to say that your mode are both of those numbers. So the mode is not the numbers that are the ranges, but the middle of them. So you're going to say the mode in this case is, in blue here, it's going to be halfway between 140 and 150 and halfway between 110 and 120. So the mode is now 115 because that's halfway between 110 and 120, and 145. And finally, the median is equal to 130. Now, for example 3, we're doing the same thing again, right? We've got the students in the French club that recorded their final marks for grade 9. And here are the marks. Okay? And here's what we're going to do. We're going to display the stuff on a histogram just like before. Now, when you graph this thing, you've got all of your points kind of done, but then what you have to do is you're going to make sure that you put your dots in between, in the middle of each column, so that you can kind of connect the dots and set up a graph if you want. So here we go. So I'm just going to kind of connect the dots. And you'll now notice that our graph kind of has a skew. And it is skewed, right? Now, the type of distribution is present. It is called skewed. So let's answer that in the next question. So they want us to identify the distribution. I'm going to tell you it's skewed. Now, the reason why is because the shift right means when you're looking at all those numbers on our graph, it means that their marks are actually pretty high. And that's what it tells you. That is what the graph tells you about the distribution. All right, let's see if we can measure the mean, the median, and mode. So in order to calculate the mean, this is what you do. Well, we have to have some sort of sum divided by the number that's there, right? Now, I'm going to go and write numbers on our graph so we know what numbers we have. We have 1, 1, 6, 2, and 4. So that means the number of people in the French class are the total of all of these numbers that are here, that are on the top of these things here, or you read them directly from the graph, from the table. So that total is 14. So we have a mean divided by 14, right? So now we have to figure out what our mean is. Think about how we did our mean from our tables before, or our graphs from before, or that question where we had all of the different prizes, right? So for a mark of first column, you're going to say the mark is 55. Then you're going to times it by 1 because there's only 1. Then you're going to add, well, for the second column, you have 65, don't you? And then you're going to times it by, well, you guessed it, it's frequency 1. And we do the same again. Plus all of that. So it's kind of like you're taking the average of each column and multiplying by the frequency of each column, and then dividing by the total number of people that are in the group. And you end up with the following answer. And you find that the mean is 85%. Now, let's say that I need to find something like the median, right? For the median, what you have to do is you have to either look at the graph and determine where the middle number would be in our list. So here's what we normally did. We always found the midpoint is equal to, well, it's 14 divided by 2, which is 7. And remember, it's even. So what we needed to do was find 2 points and average them, right? So here's how we do this. So we need to find the 7th. We need to find position 7 and 8, right? So here's what we do. Let's count it on our graph, on our information table here. So we have 1, 2, and we get to 3, 4, and we have 5, 6, 7. So 5, 6, 7. So we used up all of that, and guess where it is? It's in the 80 to 90 column. So that means our median is actually 85%. So we're always using the middle mark. Now, what do you think the mode is? The mode can literally be read from the actual graph. You just look for the highest frequency on the graph, and your mode is equal to 6. And there you go. Good luck, guys. And your homework is going to be these questions. Try your best. Don't have to do them all. Do what you can. Show me what you've got. Okay? Take care.